So I've been building a little board to test shutter speed of cameras, and this was the first version. I've got some new PCBs that I'm going to solder up today, so I'll give you a little demo of how this one works. There's three little sensors, light sensors on the back that look through some little holes to the front. Little ESP32 with Arduino code on it, and what you do is effectively place that, align it on the back. I often stick it on with some kind of blue tack and put some kind of light in the front, click the button and it prints out the shutter speed. So I'm going to solder up the second one, show you what's involved, and then get it working, show you the new interface. So I'm going to solder this up now. One of the nice things about this build is that the PCB has kind of all the mechanical structure you need. You've only got 3 light sensors, 9 resistors and 1 microcontroller, ESP32. So it's quite a straightforward build. So I'm going to put these on now. So if I get these, we need to just bend the legs slightly. So they're going to sit aligned with these. Now the trick when you're soldering these on is to feel for the little hole at the front of the lens of the light sensor, so you can get that aligned. And then what I do is hold that on with a bit of blue tack. So I'm going to set that all up off camera because it's not very exciting viewing, and then we'll come back and solder. Okay, so that's now held on with a little blob of blue tack. It's a useful little trick for holding things in place. I'm going to just solder this on. Be held. You can see now that's nicely in place to align with the hole. So I'm going to put the other two on off camera and then come back and show you how I solder on the little resistors. Okay, so we've got 3 of the light sensors attached and they're all aligned with the little holes that plug through the back. So now I'm going to attach the resistors, solder on the resistors. So we've got 3 2K resistors, so I'm going to just pop these out. Now they are surface mount, but I've tried to use quite large surface mount components, so they're, at least you can pick them up. Ping around though. Okay, so what I'm going to do, how I like to do this, is put a little blob of solder on one side, like that. They're all marked so you can see them on the board. And then with the tweezers, come back in and just attach one side, attach one side, and attach the other, and then come back and just solder on the other side. Delicate, but if you're working on cameras, probably no more delicate than dealing with the mechanisms there. Okay, so that's the 2K resistors in place. I'm going to put on the 1K ones off camera because, again, not that exciting. Okay, that's now all the resistors in place as well. I'm going to put the ESP32 on. I'm only going to solder the pins I need just in case I decide to reuse this for something else. I like to avoid wasting it. Makes it easy to get off, so I'm just going to solder one pad on first, get it aligned, and come back and do the rest. Okay, so that should be done. I'm going to need to program the Arduino next, so I'll show you that and then we'll give it a try out. Okay, so open the Arduino sketch. It should launch in the Arduino IDE. You're going to need to select the board, so it's going to make a go, and select your serial port, then click upload, wait for it to compile, which takes a little while these days it seems, and then once that's done it should upload to the board, and that should be that. So once that's actually uploaded, you can open the serial monitor, and you should, when it connects, see a little message that says ready to measure. Okay, so let's give this a try. Here's the soldered circuit board. Plug it in, get some lights. Now, what I tend to do, you can stick this on however you want really. I've found that using a little bit of blue tack works quite well and is quite a solid attachment. I was initially worried about getting blue tack near the shutter, but actually it stays pretty clear. So you can use these three little holes to look through the back and align it with the aperture for the shutter. So that gets on nice and accurate. You can always check it by putting it into bulb mode and having a look through the other side. So now what we do is wind it on. I've got this little LED panel which actually works really well. Gives a nice sort of even light. Hold that in front, and if we do that we should, let's just turn on the serial monitor so we can see. There we go, actually it had printed out. Let's run it again so that we can see it happening. There we go, and that's saying that it's about 1/200th of a second and it's set to 2/50th. So yeah, this camera's actually overexposing slightly, which is one of the things I want to adjust. Now I'm now going to show you the new Bluetooth interface. So if I open up Chrome, you can see there's this shutter tester UI. Now this is using web Bluetooth, which only works in Chrome, but it does work really well. So that connects via Bluetooth, and if we select 1/250th, so it knows what we should be at, and then we wind it on, you can see that measurement came straight in there, and it'll take a couple of measurements, average them, give you a reading. So we can also then change to a different speed. Right, let's just go ahead and benchmark this camera. Nice and quick, so we can go, let's go all the way down to a second. Bang on, wow. Actually you can add, so we can do 2 seconds, you can add 2 seconds, add that in. Let's do 2 seconds. Oh, again, bang on. Now you can see here we've got the 3 sensors. They're the timings for how long they're open, and we've also got the timing between the first shutter, between the first sensor and the second sensor, and the second sensor and the third sensor, and then the second shutter across as well. So you can use this to work out, so we can turn off the sensor data and look at these. You can use this, you can see this is actually pretty well balanced, that they're broadly the same across shutter 1 and shutter 2. So that's quite a well balanced shutter. But if we go on and let's do half a second, put it in that mode. Yeah, that's pretty good. I can turn on the sensor data again, so you can sort of decide which data you want to see. Let's do 1/4 of a second. Yeah, nice and quick. So this is pretty bang on at the slower speeds. So So 15th of a second, starting to get off, so underexposing slightly. 30th of a second, still well within reasonable limits. 60th, and then if I go up to 500th, because I've done the others, now that's getting quite off, and then 1000th, yeah, a little bit all over the place. Let's see, we'll get to another 2000th. We'll put in one of the 4000s. Now there's no compensation for the sensor width yet, so that's something I'm going to be adding in the future. The hole's I think 0.7 mil, so it's quite small, but when you get up to high speeds it's probably going to have more of an impact. Yeah, in fact that's not even registering there. There we go. Okay, so that's the new Bluetooth interface. You can choose whether you want it in EV units, which gives you quite a nice view, so you can see how far off it is by stops, or if you want to see the actual equivalent, 1/seconds, do that, or if you want to see it in milliseconds, you've got that as well, which probably is less useful, but show it anyway. So that's the new version of the little shutter tester. Hope you like it. Don't forget to like and subscribe. If you're interested in giving this a try, get in touch on GitHub. There's the discussions there, and I'm also considering doing a medium format version of this. So there's a much wider range of medium format shapes and sizes, so if you're interested in helping contribute to that as a kind of open source effort for the camera community, then get in touch there as well. Okay, cheers, bye.